Right, this is a proving problem, and let's do part A. It's pretty straightforward. We always start by letting Z and W as something. So in this case, I'm going to let Z be A plus IB, and let W be C plus ID. Right, and so we know that conjugate of Z is A minus IB, and conjugate of W is C minus ID. And we're gonna go from the left hand side, and we'll show that in the end this is equivalent to a conjugate of Z plus conjugate of W. And we're going to group this. So if you group this, you have A plus C plus P plus D, and the conjugate of this would be A plus C, still within brackets, but minus I B plus D. Okay, so if you expand, you regroup this rather, A plus IB, and this would be C minus ID, A minus IB and plus C minus ID. And what's this then? This is actually conjugate of Z, and this is conjugate of W. QED proven. And so let me put this line here. Okay, the next part B. Part B a bit tricky, but just a good sound understanding of trigo would be enough. So what we do is we let our Z be something like R1 cis theta 1, and let W be R2 cis theta 2. We do not know what Z and W, so we just let it be anything. And let's multiply this Z multiplied by W. So this is R1 cis theta 1 times R2 cis theta 2. I'm going to collect R1 and R2 and try to deal with cis theta 1 and cis theta 2. Now cis theta 1 is actually cos theta 1 plus I sine theta 1. Cool? Is that cool? Alright. This is, and cis theta 2 is cos theta 2 plus I sine theta 2. And now we expand it. Now we'll just keep R1 and R2. It's not going to affect our result, and not at the moment. So this, you have a cos theta 1. Now if you expand this and collect the right ones, the real part and imaginary part, you end up with this, a cos theta 1, cos theta 2, and minus sine theta 1 times sine theta 2, and plus I, and this is a very the imaginary part, so when you expand, make sure you get it right. So this is sine theta 1 cos theta 2, and you have plus sine theta 2 cos theta 1. And what is this actually? This is in fact R1 R2. The real part of this is in fact, if you think about it, is actually cosine theta 1 plus theta 2. Right, and this is I, and this sine theta 1 cosine theta 2, and sine theta 2 cosine theta 1 is in fact sine theta 1 plus theta 2. Check it. Isn't it cool? So means this is equal to what? Cis theta 1 plus theta 2. And so if we try to get the argument of Z times W is theta 1 plus theta 2. But what is theta 1? Theta 1 is in fact argument of z, and theta 2 is the argument of w. Short QED. Isn't it cool?